Hello, everybody. Welcome to the Database Group's 15.10 planning. My name is Roger. I am a senior product manager supporting the Database Group, and with me is Alex. Would you introduce yourself, Alex?
Hello, I'm Alex, the engineering manager for the database group.
Cool. We're going to talk a little bit about the Database Group and what we're going to be working on and where we are. In 15.10, we're expecting to be about 70% capacity, while two of our team members proceeding with their onboarding and ramp up, and we hope to be at full capacity in about one more milestone. For planning, we've got a number of top priorities and as well as a number of high severity focus items that we want to share with everybody. Let's start with primary keys to begin. Alex, I know this is a thing that came up a little bit last minute. Can you give us just a quick history lesson here?
Yeah, so GitLab's predates. GitLab has an old Rails repo, and early Rails, the default was 4-byte integers instead of 8-byte integers, and we have some tables. About a year and a half ago, we migrated a bunch of our largest tables so that we would not run out of integers in them. But there are a few tables that still have 4-byte integers that we didn't migrate, and we've been monitoring those over the last year and a half, and they've all kind of hit a saturation point where we're a little concerned about them. So we have three that we identified. We have four that we identified as high priority, with our team taking on three of them, and then we have another team that's taking on the fourth one. So big thanks to the pipeline authoring team for taking that on.
Yeah, and we expect this work to probably span a couple of milestones, but we don't think it'll be super heavy lifting after just giving it time to run a lot of these migrations in the background. Is that right?
Yeah, that's correct. So it takes a minimum of 3 milestones in order to do these migrations, because they have to run in the background, and we have to wait a period of time for them to finish migrating before we upgrade self-managed customers, because they can only upgrade one milestone at a time. So it takes a little bit of time, which is one of the reasons that we really have jumped on this. We actually jumped on it midway through the last milestone, and my hope is that this will only be one or two, a theme for one or maybe two more milestones as we finish the cleanup process.
Yeah, that makes sense. And just to clarify for our viewers as well, so like we are already creating all net new tables using 8-byte integers. So this is really just burning down old tables that have cropped up as problematic, but we don't expect this problem size to increase over time. We might discover some new tables in the future, but we believe this will put us in a good state for probably the coming year or so.
Yeah. So Rails changed their default a few versions ago. I don't remember which major version that was. Maybe 5. So by default, all of our primary keys are 8 bytes now.
Cool. Yeah. So that's like probably the newest item on this entire issue for us. So hopefully that's a little bit of context for our readers or viewers. Next up here, we have batch background migration. So I think this is definitely a continuing item for us. There's a few interesting updates here to share. Our overall goal here with this work is to minimize downtime caused by large data migrations. And one exciting question we've been trying to answer, and this is just technically difficult, is like, how long does a migration take? So we've found some ways to measure some time in our testing scenarios, and we're going to spend some time observing for patterns. And really the hypothesis here is, can we see how our execution times in testing maps to production execution times? And if so, then that allows us to formulate some estimates. And if not, well, we'll think about it some more and see what else we can do. But definitely, there's also some other improvements here. Alex, maybe you can touch on it in terms of just the general parallelization effort that will help speed up some of these migrations.
Yeah. So for both us and self-managed customers who are running these migrations in the background, we can now run more than one of them at a time, which is a change from how we ran them previously. We used to run them all sequentially. So now we haven't been able to parallelize within the single migrations themselves, unfortunately, because of the way it iterates over the table. It uses a sliding window. So in order to make sure we're not running a migration twice, we can't do the same kind of parallelization that we did with other migrations, but rather we are able to run more than one migration at a time. So we started off with just 2, and I think the plan is to go to 6. And we're working on making that configurable. So if we need to raise or lower that limit, we can.
Yeah, so that's definitely something super exciting, and we're hoping it's going to deliver real value for some of these running migrations to see some real improvements in speed. The next theme up here, again, a continuing on theme, is automated database testing. I think for a long time, GitLab has been working to improve our database testing. And the core question we want to answer here is, when a merge request is created, what kinds of new queries does it introduce into our system, and are those queries performant? So one really exciting progress update here to share is we have prototyped a query interceptor, which basically allows us to build a Rails and Postgres agnostic solution. Now, of course, for now, we are primarily focused on helping GitLab scale and making sure that the queries we introduce are stable and consistent and scalable. But the existence of this query interceptor architectural model basically tells us that, we have optionality if we want to try to build this a different way. So one of the things we're going to come up here is to really focus on an architectural blueprint for how we want to move forward and develop some of this work.
Yeah, we've taken a lot of time on this topic over the last 3 milestones, and we've been bogged down in a bunch of different ways. And as a team, some of the engineers and I talked about this together, and Roger and I talked about this together, and we decided it was better for us to take a step back and just look at the big picture and figure out what a path forward is going to look like, leveraging both this query interceptor and any other integrations we may want to build with the GitLab product.
Mm-hmm. And the last sort of bigger topic here is to identify schema inconsistencies. We introduced this a couple milestones ago recently, and really the question here is, schema divergence is something that we know exists, but we don't really have much visibility into it. And so the first thing we shipped recently is a mechanism to identify index divergence. And the next step we want to do is to start surfacing some of this information back to GitLab via usage ping, so that we can have an estimate of the size of the problem and prioritize how we want to approach it. Alex, do you want to share a little bit more context about just why we started to focus on index divergence?
Yeah, so not only this comes a lot out of our support requests. So one of the number one reasons that people have troubles with migrations is because their schema doesn't match what our expected schema is checked into the GitLab repo. And in fact, GitLab.com has the same issue. We have a few tables that don't match how the schema looks in the repository. So what we're hoping to do is use these tools not just for ourselves, but to help identify themes among our customers, so that we can identify the biggest problems and solve them, so that we can reduce some of that support volume and free up our support people to work on other important tasks, like helping people solve other bugs, right? So
yeah, that's definitely a super good point. And so now that brings us to 2 high severity focus items, and again, items that we've been working on for some time now. The first here is just removing old migrations. This is something that GitLab does frequently with every major release cycle, and we are probably about 1/3 of the way through our current workflow, and we'll continue with some of that. And then the last item here is CI partitioning support. And again, this is quite a bit of an ongoing problem that we've been working through. Just for context, our target table size for partitioning is 10 gigabytes. Our CI tables are over 1 terabyte in size. So we've got quite a bit of work ahead of us. And currently there are 6 total tables we're focused on. And in the last chat, Alex, you and I talked about zeroth partition for our viewers and what that means. And so far we've done that on the easiest table. We've taken some lessons that we've learned, and we're going to apply it to CI builds table next and sort of chip away at it in there. Is there anything else you want to add to that?
Yeah, we really hoped we'd get the CI builds table partitioned in 15.9 for its 0th partition, and we didn't make it quite there. And I just want to add some context around that. It's a much more complicated table. For one thing, it required us to break any last lingering Postgres 11 support because it requires partition foreign keys. The other thing that it has that the other table didn't is just a lot of indexes and a lot of other tables referencing it. So we've had to make a lot of changes around being able to add this 0th partition that I don't think we quite had the full grasp of when we started, but it's going to make partitioning large tables like this a lot easier going forward because we'll build a lot of these tools and have them in place. So
cool. Well, thank you so much, Alex. And thank you everybody for watching. And this is Database Groups 1510 Planning. Have a good afternoon.
thank you, Roger.